Okay, are we on? Great. So, hello everyone. Good to see you all here. Despite the restrictions, great to see quite a few of you come along here. I've given this talk twice before, once online, and I did manage to give it in person at NDC Town over in Kongsberg a couple of months ago. And I have to say, it does work so much nicer in person. So good to see you all here. Thanks for coming. So welcome to Solid Revisited, and we will revisit that title as we go through the material, of course. So I'm Phil Nash, developer advocate at Sonos. If you've seen any of my talks before, you may have seen a JetBrains logo up there before, but I'm now at Sonos, so I've got the t-shirt as well, just to emphasize that. So, Solid Revisited, the state of the matter. What are we talking about here? Obviously, the solid principles. Who's heard of the solid principles? So, just about everyone. That's a good start. Right, who can actually tell me what they all are? I'm not going to ask you to recite them, but who thinks they know them all? And of those few people that said that, who thinks they really know what they all mean? So this is a set of principles, design principles, that we're meant to sort of take quite seriously and follow in our development. And yet, nobody in this room that was interested in the solid principles and came here actually knows what they are. Unless, of course, you thought this was an introduction to the solid principles, in which case, maybe there's still time to revisit that decision. Actually, if you don't know what they are, you hopefully will learn quite a bit about them. Although I'm not going to use the traditional approach of going through them one by one and discussing them. It's going to be more about tearing them down and rebuilding them, and just seeing what's behind them, and also a little bit of a history behind them. Now, I didn't actually set out to write this talk originally. It sort of evolved out of some ideas I'd had kicking around. I do a TDD training course where I talk about the solid principles, and I realised that I don't really talk about them. I sort of talk around them, and I reference a talk by Kevin Henny, Solid Deconstruction, which he did at this conference a few years ago, which is a great talk. We'll actually discuss it a bit more later as well, do a bit of a meta review. There'll be references to all of the additional material that I'm going to mention through the talk, by the way. At the end, I'll give you a single link you can follow. So you can find that talk easily. And a few other talks as well. So yeah, as part of that material I do in my TDD training, I thought I'm not really doing it justice. So finally decided to put this material together. But I first did it as more of an interactive thing at the Extreme Tuesday Club in London earlier in the year. And I managed to get Kevin Henny and Dan North, who is another talk that we're going to talk about as part of this material. They both came along, so we had quite a discussion about it. So I've got extra material to go in. So that's really what this is all about. So maybe it'll become clear as we go through. But let's start with that history. If you weren't too sure about the solid principles and you did a Google search just to find out, where should I get started? You might hit this blog post by Bob Martin, aka Uncle Bob. I'm sure you've all heard of Bob Martin. Obviously, the one who put the solid principles together, although some nuances there, we'll get to that. So 2009, this came out, it's a little while ago now. But he does say, I'm often asked how shall I get started with the solid principles? So yeah, it seems to be the right place to start. But then in that first things first section, he says, you can read about the solid principles here. It gives a link. Great, let's follow that. And unfortunately, it takes you to this site, which is Choose Vacation Rentals. Unfortunately, he no longer is in control of the Object Mentor domain name. It's been link jacked. In fact, most of the links in that article now resolve here, so not so useful. Of course, we have a solution to that, the Wayback Machine. So we can find what he was referring to. It's this Design Principles and Design Patterns paper from about 20 years ago now, a couple of decades. And it's quite a long paper, actually. It's an interesting read. So it's got, as it says, principles and patterns, put some side by side. So just picking out the principles that he talks about, And we're just going to use the three-letter acronyms for now. We'll get to the names later. These are the principles that he talks about. So you might recognize some of them, but there's a few more. If we wanted to follow these, we might say that we're following the old Dirkacas principles, which doesn't quite roll off the tongue as well, which might be just a throwaway joke, but actually there's a serious point behind that. Looking at the first four, okay, maybe we can get the oldie principles. That's a little bit more promising. They are getting quite old now, but yeah, these are part of what we now think of the solid principles. It's only a bit later that he added SRP to that list to get, well, the soldy principles. It's still not quite there. Well, forward a couple of years, 2003, beginning of, Bob Martin released this book, Agile Software Development, Principles, Patterns and Practices. And from chapter 7, what is Agile Design? He then introduces this set of principles. Notice, still in the order, soldy. So we haven't actually got the solid principles yet. We've got the actual principles themselves, but not that acronym. 2005, so a couple of years later again, Bob Martin writes the principles of OOD, or principles of OOD. And you notice at the bottom there, we've got those principles listed in now the order of solid. Just to make it a bit easier to read. Still blurring out the actual names for now. In fact, he then goes on to talk about those other principles as well from the earlier paper. Interestingly, in that whole article, he never once says the solid principles. So he's got them in the right order, but not by name yet. What happened in the meantime, though, was it had a conversation with Michael Feathers. Neither of them can remember exactly when it was, so I can't pinpoint that. But sometime between 2003 and 2005, Feathers said, you know, if you just change those last two around, you've got a nice acronym there. This is the first that I could find he actually put them in that order. Sometime after that, he started talking about the solid principles. So we've got a bit of a timeline. All these things that we just talked about from 2000 to 2005 and on. But there's also a little bit of a prehistory here. Because while we credit Bob Martin with the solid principles, he didn't actually come up with the underlying ideas, at least not all of them. We actually have to go back as far as the 70s for that. 79, Tom DeMarco wrote Structured Analysis and System Specification. And a big section there is about cohesion, which forms the basis of SRP. We'll talk about that a bit later. 1988, Bertrand Meyer, Object-Oriented Software Construction. We get the open-close principle from that. We'll talk about that later as well. Also in 1988, Barbara Liskov, Data Abstractions and Hierarchy. And we get well, she didn't call it the Liskov substitution principle, but that's where we get that from. And then in the mid-90s, Robert Martin himself wrote a series of papers for the C++ report, where he picked some of those ideas and added a few of his own. And that, between all of those, that's where we get those 5 principles. And you notice they even come in more or less in chronological order. So that was quite nice. And the rest, as they say, is history. We will actually come back to some of this historical context a bit later. So it's not just as an interesting aside, but let's actually look at the principles themselves. So not many of you actually said you knew what the names were, so I'm not going to get you to call them out, but we'll just very quickly sketch them in. So SRP is the single responsibility principle, and it's probably the most important one. In fact, many of the other principles are derivations of this, one way or another. And in terms of how the principles interact with things like TDD and just good design in general, everything generally comes back to this. The open-close principle, well, I mentioned that by name from Bertrand Meyer. But we say things are open to extension, but closed to modification. There's still some digging we need to do there, though. We also mentioned the Liskov substitution principle. Interface segregation principle, you can think of as basically the single responsibility principle, but applied at the level of the interface. And the dependency inversion principle, best known for being confused with dependency injection. I find myself saying the dependency injection principle sometimes. There's a relation there, but they're not the same thing. OK, so they're the principles. So we're not going to dig too much into each one on their own merits, but we will sort of peel them apart a bit. I mentioned a couple of talks that have actually tried to tear them down, rebuild them. I particularly mentioned this one. Kevlin Henny's solid deconstruction. So here he was doing it at NDC London, another NDC event. Anyone here seen this talk already? Oh, well, you've got some watching to do. It's a great talk. And we'll dig into it a little bit more. But the other one, Dan North's Why Every Single Element of Solid is Wrong. It was a lightning talk, so you can give him a little bit of sort of emphasis there. Unfortunately, this one, I don't think there's a recording of it online, but you can find the slides. But that's mostly what you need to know.
It was PubConf.
Now, both of these, they've also proposed their own acronyms for a set of principles, maybe slightly lightheartedly, maybe more seriously, depending on how much they've had to drink when you ask them. Kevlin proposes the fluid principles, and we'll look at those a little bit later. Obviously, a play on solid. When I did that XTC event with Kevlin and Dan, Dan said that he'd been working on his own set of principles, and he wasn't quite ready to announce it yet. But since then he has. He's written a blog post on it, which I'll give you a link to. So he's proposing the Cupid principles. And he is a little bit more serious about this. So that's worth looking at. So we'll dig into the references there. We're not going to go into that one too much. But let's start with what his lightning talk was about. He does a lot of this. So he's talking about the single responsibility principle. He says it's the pointlessly vague principle. And this really gets to the heart of the biggest problem with this one. The principle itself is fine. It's actually the most important one. It's the naming. I mean, he says it's pointlessly vague. Maybe that's over the top. But it is hard to really get to the meaning of the single responsibility principle. What is a responsibility? Why can we only have one? What if two responsibilities belong together? Lots of questions that need to be resolved. It's hard to actually do something with it, even if you can sort of intuitively get what the idea is behind it. So not... There we go. Don't know what happened there. So he proposes instead, write simple code. OK, that makes sense. You could argue that's also a bit vague. But actually, I think he's onto something here, and we're going to come back to that topic a little bit later as well. I do like this expression at the end, though. Refactor until it fits in your head. This is one of Dan's favourite phrases. He uses it a lot. And I think it's typical Dan North, sort of practical, pragmatic insight. If something can fit in your head, then it's simple enough. And if it can't, well, you need to refactor until it does. That's actually an actionable principle there, so I really like that. But in fact, this idea of writing simple code turns out to be his answer to all of them. So, as I say, I think he's actually onto something there. We'll touch on that a bit later. Let's have a look at Kevlin's talk. So, going through these one by one. Kevlin says that the single responsibility principle is really just Tom DeMarco's idea of cohesion, that things that belong together should be together, but things that don't belong together, of course, shouldn't. And Kevlin adds in this idea of adhesion as being the opposite. So, yeah, things are stuck together, but really they shouldn't be together. They're adhesive. And it's a nice concept to keep in mind when you see that in code. Oh, that's adhesive code. Gives you a name for it. Separation of concerns is another way of talking about it, which is maybe slightly better than single responsibility. Kevlin gets more to the heart of what it's actually about. But cohesion is really the core concept. So it's a shame that it got renamed to something that was less useful. OCP, I think you could summarize Kevlin's view as, well, it just means use polymorphism, but also, separately, don't publish interfaces prematurely. And what he means by that is that the part of the open-close principle, that the closed part, closed for modification, that feels a bit dated. Rooted in the 80s when it was expensive to change code and to track it. We didn't really have version control systems. We did that, but they weren't widely used. So yeah, we had to be very careful about how we modified code. Now, of course, we should feel free to change our code easily. That's a big part of this, being able to change, embracing change. But as soon as you've published an interface to something outside of your project or team, maybe even outside your company, as soon as somebody else is relying on it, now you've got a contract with them. And at that point, you are locked in, at least at the interface level. So don't do that too soon, is just the advice that he summarizes from that. So, okay, that's maybe not the takeaway most people get from the open-close principle, so that's interesting. And then the Liskov substitution principle, perhaps the most misunderstood of them all. Again, he summarizes it really as use polymorphism, again, but carefully. And really what he meant by that, and I think this only really came out in the discussion at XTC, was that the Liskov substitution principle, the bit that most people misunderstand, is that it's really about contracts, again. If you have a contract on your interface, guaranteeing what the behavior is, that contract must be preserved across polymorphism. So something can do something different as long as it obeys the same contract. You get the same guarantees, post-conditions, preconditions. That's the sort of contracts we're talking about. Not normally in the discussion of the Liskov substitution principle, but that's really what it's about. So that was quite insightful, I thought. ISP, just single responsibility principle for interfaces. So he claims that's a bit redundant. Do we actually need a whole separate principle for that? Tend to agree. And the dependency injection, I did it again. The dependency inversion principle is really, again, use polymorphism specifically with interfaces rather than implementation, inheritance specifically. So you can see some common themes there. There's a lot of the same thing being repeated. So in fact, you can regroup them, and you get some sort of graph like this. Got three main areas. The cohesion part, separation of concerns, is quite central, and using polymorphism with interfaces, do it carefully. Respect contracts. And that extra bit on the end, don't publish prematurely, which is good advice. I'm not sure it really qualifies as a central principle that we should be following. So really it just boils down to those two things. Cohesion with polymorphism. You can summarize the whole of the solid principles as being about. So that really summarizes Kevlin's talk. There's a lot more to it and lots of extra bits of history and insight, so it's definitely well worth watching, but this is my main takeaway. He has a lot of good points, and as Kevlin always does, interesting asides, but I don't necessarily agree with everything he said. And in fact, at the end of the talk, and we'll see if this audio works. Is that going to work?
Maybe you didn't agree with everything. In fact, probably if you did agree with everything,
okay.
You weren't listening.
The audio didn't work, but hopefully you read that. So, yeah, Kevlin's talks are not designed to do thinking for you. They're designed to make you think. So he will say things that he doesn't expect you to agree with, but if it gets you thinking, then that's his job done. And this is no exception. And I think that point's missed in a lot of the criticism of this talk. So he's not saying the solid principles have no value or they're completely wrong, but maybe we just need a more sort of modern view of them, and maybe we can simplify them a bit. Now, looking at this slide from his talk, This is an example of something Kevin likes to do in just about every talk he does. Takes a picture of some of his books, usually on a floor or some other surface. And I quite like this idea. And as it happened, on the same day at the same conference, I was giving a talk in another room. And I said, what Kevin does about these books, I like the idea. Problem is I don't actually read physical books anymore. So I took a photo of my iPad on the floor. Now, the reason I'm throwing this in is because that talk was about simplicity, as it happens, which, as Dan North already said, he thinks that's really the central theme to the solid principles. Coincidence, we're just talking about the same thing in the same room on the same day. We'll come back to how simplicity ties this all together a bit later, but just to set you up there. Okay, so what really are then the problems with the solid principles? I've hinted at some of them already, but let's actually call them out. So, a whole set of criticisms that have been levelled at the solid principles. We're going to pick these off and see whether they apply. They're not actually principles, was one of Kevin's points, actually. Not excessively named. There's these internal redundancies. As that graph showed, you can actually divide up into really two principles. Maybe some of them are outdated, like the open-close principle, or maybe they're language or OO specific. Well, let's take that first one first. Are they even principles? This is one of the questions Kevin asked, and I think he quoted from the Oxford English Dictionary for the definition of what a principle is. I pulled up this quote from the Cambridge Dictionary. It says very, very similar. There's a reason I've chosen Cambridge I'll come to in a minute, but it says it's a basic truth that explains or controls how something happens or works, or a basic idea or rule that explains or controls, again, how something happens or works, or a moral rule or standard of good behaviour for fair dealing. And Kevin says, well, these are not truths, they're not rules, and there's nothing moral about them, so why do we call them principles? And you can sort of see where he's going. But if you read on in the Cambridge Dictionary, there's a little aside about in principle, where it says if you agree with or believe something in principle, you agree with the idea in general, although you may not support it in reality in every situation. That actually sounds a lot closer to the meaning that we think of when we think of the solid principles. Yeah, they're good guiding principles, but they don't necessarily apply in every situation. You've got to use your own thinking there. So I actually disagree with Kevin on this one. I think that we're okay to call them principles. In fact, in that article, Getting a Solid Start, Bob Martin, he has a section, what do I mean by principle? And he says the solid principles are not rules, they're not laws, and they're not perfect truths. They're statements on the order of an apple a day keeps the doctor away. It's a good principle, it's good advice, but it's not a pure truth, and nor is it a rule. It's almost as if he read that dictionary definition and said, no, that's not what I mean this bit. And given it is actually there in the dictionary, I'm happy with that. And I don't think anyone's really been misled by the use of the word principle here, so I'm happy to tick that one off. But I'm not going to let him off the hook quite so easily, because he actually continues in that same article. The principles are mental cubbyholes. They give a name to a concept so you can talk and reason about that concept. So if the reason for introducing the principles is to give a name to it, did he actually do a good job of that? Which leads us on to the next problem, that they're not accessibly named. By that I mean, looking at those names, do you immediately know exactly what you're actually trying to do with them? I think we've already hinted that there's some problems there. Looking at the single responsibility principle, well, Dan North called it the pointlessly vague principle. It's hard to do something with that. You sort of intuitively know what we're getting at, but what's the action required there? You need to dig a bit more and know about cohesion and how that applies to code. The open-closed principle, problematic as well. It's simple enough to say, open for extension, closed for modification. Again, what does that really mean? Should we really be, stopping things from being modified? We already said maybe that was rooted in the 80s and we can move on from that. It has a slightly different meaning. And even the open to extension. Bob Martin's interpretation was extension through inheritance and class hierarchies, which is maybe something we're sort of moving away from as a unit of reuse these days. But actually, if you go back to Bertrand Meyer, he was talking about functions and modules as well. So the idea of being able to extend things is a bit more general than what's been captured in the solid principles. And it's very difficult to get all of that nuance just from the name, which is why most people go away and think, yeah, I know what that is, and then they basically forget. The discourse substitution principle. Well, it's based on somebody's name, which is not that helpful. Okay, it has the word substitution in there, so something to do with substitutability, but really the meat of it is in the bit that's not there in the name. Again, it's about those contracts and how it relates to behavior. You do need to dig quite a bit more to really get to that meaning. Interface segregation principle, it's fine if it's useful as a principle, but maybe it's a bit grand sounding for something that's actually quite a simple derivation of one of the other principles, but there you go. Similar with the dependency inversion principle, it almost obfuscates the actual simple meaning behind it. Yeah, we can get there in the end, but I'm not sure this is actually that helpful in understanding it. In fact, there's an even bigger problem with this one, maybe best illustrated with this. Anyone know what this is? Although I'm not sure I'd hear you in this room with everyone's masks on, so maybe I shouldn't get you to call out, but normally somebody eventually says upside down glasses or something. You put these on and you see the world upside down. And the purpose of these is like part of an experiment, because the theory is that when we're born, well, not theory, it's a fact, when our eyes are wired to our brains upside down, we literally see the world upside down. But within a few days after we're born, our brain flips it. And we go the rest of our lives seeing things the right way up. Until, of course, we put these glasses on, and then it flips it back again. But if you keep them on for a few days, and why would you, unless you're doing this experiment, but apparently it will flip again. Brain's an amazing thing. But what's this got to do with the dependency inversion principle? We've got the word inversion in there. And the point of this is to point out that it's context dependent. What are we inverting with relation to? Are we now seeing the world the right way up or upside down? Depends what came before. So the dependency inversion principle was sort of about inverting what we used to do with our dependencies. We used to depend on concrete implementations, and now we depend on interfaces so that the lines are going the opposite direction. They're inverted compared to what we did before. But now, most people do things that way. So if you're going to invert it, you're actually going to go back to what we did before. So it's a bit problematic, but yeah, I think there are some problems with the naming. I'll definitely agree with him on that. Let's have a look at those internal redundancies. Well, we already saw this graph. It's definitely true that you can simplify this down to 2, maybe 3 key points with some little nuances. Or go as far as Dan North and say everything is just about writing simple code. But even if you try to stick to the main message of the solid principles, there's a bit too much repetition there. I'm not sure this is a terrible thing. It can be good to state things in different ways and think about things in slightly different ways. There's no guarantee these are all orthogonal. So I think the overlapping part is fine, but it's also useful to dig into the underlying ideas and make sure that they are being captured in our code. So yeah, I'm not going to talk so much about that. What about the fact that maybe some of them are outdated? We already looked at OCP, the close for modification part. I think we can agree that that's not really the spirit of Agile these days. And dependency inversion, again, it's outdated in the sense that we've moved on from what we're inverting. We don't want to go back to that. So a little bit, but most of the concepts are pretty timeless. So I'm not as worried about this part as some of the other problems. We do have that extra part to OCP about not publishing prematurely, and I think that still holds, even if we don't really talk about it anymore. Skip that. Okay, what about the criticism that solid principles are language specific? They were originally formulated in the context of C++, but these days they're probably most often talked about in the context of something like Java. What about dynamic languages? Can you apply LSP to a dynamic language? Well, when you know that it's really about contracts, then yes, absolutely, you can, even if you don't necessarily have interfaces in the language. You definitely still need to respect the contract of something. If something walks like a duck and quacks like a duck and obeys contracts like a duck, then and only then is it a duck. And the dependency inversion principle originally was talking more about the C and C++ inclusion model, which made that really tricky to work. I mean, I still work with C++ regularly. It's still a big problem. But other languages have mostly solved that in a language level. It's not such a big problem to keep those dependencies inverted, if you like. You still have to think about it, but maybe it's not such a core principle anymore. Maybe that's why it's easy to think about dependency injection instead. And again, the interface segregation principle, well, I put here interfaces less used in C++, because I think I originally presented this to a C++ audience, but interfaces as a main unit are also being questioned these days. Often packaging things up in different ways can be better, but that one's a bit more of a stretch, but definitely needs to be looked at, I think. Oh, got some extra. Yeah, we covered that. Okay. What about, oh, jumped too far ahead now. What about the OO specific? I think this one has more merit, but actually when you look into it, maybe less so. So I've put that ISP, DIP are maybe less relevant to a functional language, although I think the first time I gave this talk I got a little bit of pushback on that, and somebody said that dependency inversion principle is actually still very, very useful in a functional language. OCP still applies maybe to a data model in a functional language. SRP definitely still applies to functions. And same with LSP, substitutable types. If you're working with a functional language, all of these things really still apply, even if you maybe don't have to work quite so hard to get them, because they're sort of baked into the, like, oh dear. Okay, maybe I said functional language too much. Okay. I meant to take this slide out. First time I did this talk was at the ACCU conference. I had a 90-minute talk, so I had like a little section in the middle where I could actually discuss things. But we're gonna move on and get to the second section. Solid revisited. So having presented particularly Kevlin Henney and Dan North's criticisms of Solid and addressed some of them, I want to present my own views on the matter. But before we get to that, I mentioned some of the other acronyms, sets of principles that have been proposed, Kevlin Henney's fluid principles. I did actually find the liquid principles as well. Obviously plays on this idea of states of matter, hence the second part of my title. We could definitely say those aren't dry, but I'll leave that one there. Kevlin's fluid principles. I mean, he did this as a lightning talk. Again, I don't think it was intended to be entirely serious, but when I spoke to him at XDC, he said, no, I didn't actually mean them seriously. You decide. So he says, Your code should be functional. I tend to agree with him there. And the screen hasn't flickered, so that's good. Should be loosely coupled, which sort of gets at the single responsibility principle. Unit testable, which I agree with, but it's one of these circular things because we're generally applying these principles in order to make our code more unit testable. And we do that by making it more unit testable. So it's a little bit problematic, but I think I see where he's going. Introspective is an interesting one. I think it's quite a powerful technique that we're going to be seeing more of in the future, but I'm not quite sure it qualifies as a principle, at least not yet. It's more of an approach to coding. Idempotent, I think, is definitely a reach. Trying to get that last letter in, he didn't even quite make that. And I'm not really sure how that applies. But what is interesting about this is just the exercise of trying to come up with a set of principles that you think are meaningful and then fit an acronym. It was just a useful exercise to do. Looking at the liquid principles, these are definitely meant to be as a joke or a counterexample. Your code should be large, long files and classes with lots of interdependencies, breaking the single responsibility principle. A quagmire, undocumented, illegible, with plenty of duplicated code. So, unfortunately, I have seen many code bases that follow the liquid principles to the letter. I'm sure you have as well. All right, well, one of the problems with this, with fluid in particular, is it's not really a state of matter, it's sort of two states, because it could be liquid or gas. I didn't find anyone proposing the gas principles. Maybe code that relies too much on getters and setters. I don't know, maybe you can come up with something better. But what about plasma? Some promising letters there. Maybe we'll do something with that. But actually, if you dig enough, there's plenty of exotic states of matter that we could go with. I pulled these all off Wikipedia. I did try to get the Bose-Einstein condensate principles, but I gave up at some point. So let's go with plasma. So here is my attempt. The plasma principles. Again, it's really this exercise of, what can I actually fit into this acronym? Not intended to fully replace the solid principles. Let's have a look at these, because I think that there's something in this. So persistence. What do I mean by this? So I don't mean keep trying, you'll get there in the end. And I don't mean writing to files and databases. Really talking about persistent data structures. And I've done talks on this. Just very quickly to summarize, if you've got a tree structure like this, binary tree, could be a red-black tree. If you want to add something like that yellow node at the bottom there, if you copy all of the nodes up to the root and put it on your copy, but have links back into the original tree, the original tree persists. It's still there, and you have a new tree which has lots of shared state along with it. That's an example of a persistent data structure, if you haven't come across that before. Does this really make a principle, though? Well, it's more of a proxy for immutability, because this is a great technique for using more immutability in your code, while also giving you, rich data structures and being able to add things to them, which is particularly important with data structures. So stand in for that. So immutability, I think, is a principle worth striving for. Local reasoning is the next one. So I'm going to use a slide from another talk I did, Functional C++ for Fun and Profit. I think I actually did it at this conference a few years ago. Just to illustrate. So this is C++ code, but it's pretty universal, so shouldn't be a problem. So typical bit of code where you've got a variable, in this case color, and you want to give it a value based on some condition, in this case calling this function. Simple enough, but there's a few problems packed in there. Just a few lines of easy code, because we need to make that call in order to know what we're going to assign to it, we can't use an initialization here, which means we've got an uninitialized variable. And maybe we would initialize it to some default state and then change it, but that doesn't feel right either. It doesn't really reflect the intent. And then it has to be mutable. We can't make it const in the C++ keyword sense. So it's mutable. And then we've got a side effect in the if statement in order to make that assignment. So there's a few things that we would prefer not to be there. But the one I want to particularly draw attention to is that mutability again. So I know that's connected more to my first principle, but it's so important, I'm mentioning it again. The consequence of that is fine for maybe these few lines of code, but now that variable, its value, is entangled with all of the rest of the code that it goes through. In order to reason about the value of color, you have to look at every line of code it may pass through, because something else may change it, because we couldn't make it const. We've lost that guarantee. So we've lost the ability to reason about it locally. And it might not seem an important thing. These things really add up. We sort of think of it as the cost of doing business. We're so used to just losing track of values and what state they may be in because of the default mutability in most of the languages we work in, that we don't even think about local reasoning most of the time. But when you can get that back, and this is why it's you'll often hear functional programmers talk about local reasoning, because they do have those guarantees. It's really hard to give that up again. So that's why I put it as its own principle. Yeah, so I did propose if C++ was more like a functional language, you could do something like this, where you treat the if statement as an expression. Of course, you can use a ternary operator in this case. Most languages have that as well, but it doesn't scale very well. And the other talk I've done, I've shown how you can fake it by using an immediately invoked lambda expression. So you wrap the statements up in a lambda, immediately invoke it, and it effectively converts it into an expression. Really useful technique for getting back local reasoning. Okay, algorithms next. And again, maybe this has a bit more of a C++ bias. At least my example here, Sean Parent did a talk some years ago, C++ seasonings, where he's talking about C++ algorithms. The main message is no raw loops. So if you find yourself writing a loop out by hand, think about if there's, again, if it's C++, an algorithm, whatever language you're using will have algorithms or something similar in the standard library, hopefully. Point is, like those little loops, even if they may seem simple, they're just packed full of complexity that can come back to bite us. Use something that somebody else has actually optimized and thought through and got right instead. And then we come to simplicity. So I said we'd come back to this. This was Dan North's main idea, and I tend to agree with him. In fact, I've done a whole talk on simplicity. The one that I was giving in NDC London, same time as Kevin. Actually, that talk was mostly a riff off another talk by Rich Hickey, Simple Made Easy. Anyone seen Simple Made Easy? A couple of hands. You should definitely watch that talk. Again, references at the end. But I do reference a lot of it in my talk. In particular, this slide, these illustrations I stole from Rich Hickey. I think they really illustrate it quite nicely. So what Rich did, and I sort of did in my talk as well, was go back to the Latin roots of the English words simple and complex. So a complex in Latin means something with many folds or braids, whereas a simplex, where we get the modern English word simple from, meant something with one fold or braid. So simple enough meanings, make sense, and you can sort of see how they actually carry the meaning forward. Looking at the illustrations, if you look at the one on the left, the simple case, if you try to follow one of those strands from the bottom to the top, well, it's trivial. You don't even have to think about it. You know exactly where it ends up. But try doing that with the complex case on the right. Follow one of the strands. You've got to carefully follow it all the way up. And there's only 4 strands there. Complexity makes us lose track of things very, very quickly. And yet our code tends to be full of it. And with this definition of complexity, you can think about all the things in typical code that cause complexity, very often unnecessarily. Threading concurrency is an obvious one, and maybe we need it, but hopefully we can find ways to protect ourselves from it. Globals or singletons, if we had those in our code, they basically bring different parts of the code together as a code dependency, often in very hidden ways. Any other sorts of shared state, similarly. Mutability, coming back to that one again. Already talked about immutability earlier. Again, because it complicates the value of something and passage of time as it evolves. So it's another hidden complexity that we're sort of not used to thinking about, maybe. Cyclomatic complexity, well, it's got complexity in the name, but it's really overuse of conditionals and branches. Leaky abstractions is an interesting one. Now, we'll actually come back to abstractions in a bit. So I have another section from my simplicity talk that I'm going to revisit. Code and module dependencies, we'll talk a bit less about, should be fairly obvious, and that's definitely captured in the solid principles. So yeah, let's fast forward on to abstractions. We'll skip over modularity for a moment. So this is a slide from my simplicity talk. It's actually a quote from Joel Spolsky. You may recognize, all non-trivial abstractions, to some degree, are leaky. I grayed some words out because I think the statement is stronger if you take those words out, and I think it's still accurate. And I attempted to prove this in my other talk, where I actually talked about, for example, the evolution of our number theory over the millennia, how often that abstraction, just of numbers that we rely on every day, has been leaky at different points in time. So if we can't get that right, what hope do we have of the code that we're writing in a week? So yeah, all abstractions are leaky. But they're also probably our biggest weapon in the fight against complexity. So it's a real dilemma, this double-edged sword. So I'll go into some ideas in that talk about how to deal with it, but it basically amounts to give up on these all-encompassing metaphors for your abstractions, unless you are going for something like building a language or a standard library or something that you're going to invest the time in making it watertight as possible. Otherwise, embrace the leakiness. It's going to leak anyway, so try not to make that too much of a complicating factor when you have to deal with it. So, be careful with your abstractions. So you've probably seen this quote, George Box, all models are wrong, but some are useful. Similarly, all abstractions are leaky, but some are useful. Oh, and here's the slide where I talk about what I call global abstractions. That's those languages, standard libraries, things you're going to invest the effort in to make as complete and watertight as possible. Or local abstractions, the things you're going to have in your own code. To say, embrace the leakiness. Try to keep those abstractions shallow. Do you ever had the experience of debugging through some code and you're about 10 abstractions down, trying to work out what you're actually dealing with here? Is it this thing at this level or this thing? Those abstractions are just complicating things at that point. So we need them as an organizational unit to manage that complexity, but we've just got to be careful. Try to make them shallow and embrace the leakiness. Okay, modularity. I don't have that much to say about it. I mostly threw it in because I just needed that other letter. It sort of fits with the single responsibility principle, but no great insights there. But that is the plasma principles. Maybe you want to try your own exercise of coming up with a set of principles that you think are important and see how your own code holds up to them. But that's been solid revisited. There is the URL for where all the references to all of the other materials, my talks, the other talks I've talked about, and articles, levedarredirection.com/refs/solid.html. If you can't remember that, I also have extra level of indirection.com that redirects there. So that's the end of the talk. Thank you very much. Do we have any questions? Do we actually have the means to ask questions? Got a mic or no? But anyone want to call out? I can't see everyone from here. Oh. Last time I did this talk, I went a bit over time, so I maybe rushed a little bit too much this time. Okay. Well, in that case, thank you very much.